Hi, welcome to nuk234. This is Immersive VR Compositing in Nuke, and I am your professor Daniel Smith, and welcome back to Class 5. In Class 5, we're going to be taking our environment. We're going to concentrate on the forest and getting these layers out and rendered and into Nuke, and we're going to be going over our composite. But there's a couple things that we have to do first. First of all, I've already rendered all the passes that we're going to be using today for you, and they're included in the downloads. The downloads are quite significant this week. I think we're total about 8 gigabytes, and make sure you get those downloaded, and they will all go into, let's see, here's my working folder, but they're all going into a folder called renders. And there's going to be a AO shadow Fresnel pass, a ground pass, 2 multi-map passes, a PMAP, and a trees pass. And the PMAP is probably the most data heavy. The PMAP has some frames that are upwards of 40 megabytes per frame. So we're going to come back and we're going to look at all these different passes and why we have them and how I use them in the final images. But I want to make sure that you organize your downloads in the same fashion in Class 5 and renders, because the file that you will have, class05 comp, will reference this file structure. So as long as you have a folder on your system that reflects the same structure with assets, ground texture, renders, and trees, and all that stuff that you have that I've included in my downloads, as long as you maintain that structure, you will be fine. And you'll be able to pull up my script and see exactly what I did. With that said, I want you to have liberty to push your version of the composite within any direction you want. You can re-render a pass if you have the firepower, or you can take some of my multi-passes and multi-mats and modify and change things. So it's pretty cool. So let's get started. So before we can go into Nuke, we do have to address the issue that we're simulating a ride. And because we're simulating a ride, and we are eventually going to have some props that are going to sit in front of the screen that will be from a different distance right through here in front of the screen. And we have this, what we see through the screen. And because we're going to be having that happen, we want the reality in front of us to look like the reality on the screen. What does that mean? Well, it means stereoscopic. It means that the imagery that we're going to be putting on this movie screen has to be in stereoscopic 3D. That way, when we eventually get our visualization on an Oculus or the Gear VR or one of these virtual reality products, that stereo is a major component of VR these days. You know, there are the 360 videos and everything else, but how can you have reality without stereo? Because that is how we see the real world. So we need to set up some stereo cams. Now, that's no problem because we already have our camera right here. And let's see, let's show our camera. Okay, so all we need to really do is create a new stereo cam. So let's go up to here and let's do create cameras. And we're going to create a stereo camera rig. And now we're going to take that and we're going to parent it to the existing camera. Now, once we parent that, we want to zero out its auto translations. And that way, it's going to be, and zero out that rotation right there. Okay, so that's going to parent it right to our ride base. And we can see that there's a center cam that the rig comes with. And then there are 2 left and right cameras. Let's fix that scale as well. There we go. So now we can look through stereo. Now, how do we look through stereo? Well, let's go up to panels, go to stereo, and now we have our stereo camera. Now on our stereo camera, we can also look through the center camera or individually select the left and right. Now the left and right are going to be important as those are the cameras that we're going to be rendering with. So I want to select our stereo camera rig, and what that's going to do is going to do the viewer to show you in anaglyph what the stereo is going to look like. And this is really handy. If we go over to our stereo panel, we can see there's a couple of different options. There's horizontal interlace. If you happen to have a stereo passive monitor or a stereo television that uses passive glasses, you can actually output this to that and see it that way. There's also checkerboard, which is more of a legacy thing. Older DLP television sets used a checkerboard system to display stereo. Then you have your anaglyph, a luminance-based anaglyph, which helps compensate for the darker red areas. And then you can also do free view, where you can sit here and you can cross your eyes. I find that extremely painful, but that's okay. So I'm going to stick with anaglyph because that's the cheapest, and I've got a pair of anaglyph glasses here. And you can follow along if you have glasses or just copy the settings that I have. So I'm going to select my stereo cam. We're going to open up the attribute editor, and one of the first things that you notice is that the camera does not fit the same view that we had earlier, and that's because it doesn't have the post scale factor into it. So we need to put our factor that we used last time, the 1.9, into that. But you see, we're looking through the stereo center shape. So let's open up our cameras and make sure that we are on each individual camera and put in that 0.19. 0.19. There we go. Cool. So now we can actually see our stereo space. Now let's go to a closer frame where we are. And you can see our ride base is kind of difficult to view, but that's okay. We're not worried about that right now. Let's go back to the stereo cam and its controls right up here. Now our focal length is all wrong. We should be at a 24, just like before. We had a 24 millimeter lens, and we're gonna keep with the off-axis stereo. But what we're gonna need to do is change our separation. This is set up for 6 centimeters. That would be real-world scale. Our scene is actually about a 1/5 scale. So I'm gonna have to lower this down to maybe like 1.2, all right? And then I'm going to use this thing called the zero parallax plane. And what that is let's put that about 50. And what that's going to do is it's going to make the front area of the screen at the zero parallax plane, right around where the troll is going to be. So that way depth falls back into it, and we can have depth in front of it. Now the 3D is difficult to see, so what I like to do here is I'll turn the cameras off. So we'll turn the cameras off, and we'll also hide the lighting because it's hard to see that. And it's also better to see your approximate field of view. And my field of view is not going to be of the camera of 24 millimeters, but it's going to be closer to like anywhere from 60 degrees to 80 degrees in the focal length. And this is a closer field of view of what it's going to look like in the end of how we're going to see it from point of view in VR. What I can do is I can tweak my interaxial and zero parallax to be more comfortable, but if you do have a pair of 3D glasses, this works pretty darn well right now, and I'm pretty happy with that. So first thing we're going to do is we're going to return our focal length to the correct lens, and we're going to switch out of the stereo view and back to perspective. There we go. And let's select our camera, and you can see how close together our camera is. And the whole point here is, notice that the scale of the camera is approximately the scale of a human head. So if a person was sitting in this seat and their head was about yay big, what you want is the distance between the left and right cameras to be approximately that big. Now you can go a little bigger or a little smaller depending on your artistic interpretation, but generally in order to portray correct scale, you want those cameras to fit basically inside the head of the person viewing it. I have them slightly larger because this is such a big screen. I want to kind of bring the space down because it will cause a bit of discomfort. So that's why I'm minimizing some of that 3D, especially because the troll will be reaching out at us, and I don't want that moment to lose more of that 3D-ness and break the moment. I want it to be a really fun moment, so that's why that is. So now that we have this, we're going to have to re-export our ride base again. And we're going to have to do this again in class 7. No, not class 7, 8. In class 8, because then we're going to go ahead and we're going to start animating the ride base and getting it to add movement for the total thing. But right now, we got to get those stereo cameras into Nuke. And the best way to do that is select that motion base and go up to Cache, Alembic Cache, and export our selection to Alembic. So that is going to be set out to the assets folder, and I'm going to save out the ride base stereo.alembic, and then that's going to get loaded into Nuke. And one more thing is I'm just going to go over to the render editor, and I'm going to show you the different render passes that I've set up. And you could set up more render passes. You could do a lot more with this if you want. You have the file, but I basically broke it out into a tree pass, a ground pass that's separate. Then there's a shadow pass that these trees are casting shadows onto the ground. Then I've got a multi-map pass, which is right there, and another multi-map pass to catch the rest of the trees. I've got a Fresnel pass to create Fresnel edges. I've got an ambient occlusion, and I've got a P-map. And the P-map is an unusual pass. For those of you not very familiar with this, it's basically a position map. You can see the colors are all converging on the X, Y, and Z origin right here. And basically there's a green gradient that's being applied to the positive Y, a red gradient across X, and a blue gradient across Z. And those are going to give us positions of every single pixel. Now, I've rendered out these passes mostly as 8-bit, but the PMAP has to be a 32-bit file, and that's why it's so massive, because it's storing tremendous amounts of data. So I went ahead and rendered all these passes ahead of time for you, and let's jump over to Nuke and bring them in, and we'll go over them. All right, so here's a fresh copy of Nuke. Let's go into our project settings, and we're going to be setting this up for our project here. So we're going to choose ultra high definition or 400 frames. Let's lock that range. We're going to be at 24 FIPS. And I'm going to invoke the project script directory. And up above, we want to click on views. Now views are very important because this is a stereoscopic project. So we're going to click set up views for stereo, which creates a left and a right view. And we'll select use colors in UI so we can see those colors if we need to. and let's save out our file. So we're going to save out this file, and we'll just call this work in progress v2. And let's read in our files. So I'm going to read in these files here. So renders. So let's just bring in all these files, and then we'll talk about them in a second here. Multi-select those. Let's put those over there. Okay, so first of all, one thing I want you to notice is that there are 2 read nodes for every pair of PNG files. And there's a left and there's a right sequence. Except for the PMAP. The PMAP is an EXR. And when I loaded that one EXR sequence in, you're going to see this little green guy up in the upper left. And that means it's a view file. That means that it's got multiple views embedded within the EXR. So this EXR sequence, I'm going to view that, has a couple things on it that I used to save file space. First of all, I got rid of the alpha channel because the alpha channel we don't need. We can, if we need an alpha channel for the screen, we can generate it with our geometry or use one of the existing passes from last week. And I also have auto crop on, which this is why the bounding box is here and it changes throughout the shot. And that was able to save about 5 megabytes per frame by doing the auto cropping and the alpha channel lack of. But because it's EXR, we can store both left and right images in there. And if I toggle on the top here, you can see the difference between the left and the right. Now, these other sequences are independent image sequences. So what we have to do is, well, first of all, we could either grab a join view node, and what that's going to do is it's going to combine the left and right views together into a single image stream. But a more efficient way of doing this is what I'm going to do, which is go into each left eye and substitute the L right by the frame number with a %V. And what that's going to do is it's going to turn this into a multi-view loader. And then I can get rid of the other eye. So now this image and this image will now be stereo. So %V, get rid of the other one. In fact, let's just get rid of the right eyes altogether. And we'll just pop those up there. There we go. And let's just put that %V over there. And over here. And here's the last one. Awesome. So now each one of these is a stereoscopic render. And we can see that. We can toggle our left and right. And we can see that there's a discrepancy or a disparity in the stereo views. And this allows us to treat everything as a normal composite. It just happens that it is stereo. All right, great. So I want to go over a couple of these passes now. We've got our tree pass, and the tree pass had the ground in it, subtracting away from it with a blue with a black hole shader. And that way it's got a clean alpha channel and it's ready to be comped directly onto the ground. So if you actually merge this directly onto the ground, you'll see that there's no geometry poking through the bottom, or it's actually cutting directly into it. Then we have our multi-mat passes, which allow us to select the far trees, the twigs, the mid trees, and then this other multi-mat pass, which allows us to select the foreground trees, the midground trees, and the ground, all separately. So those are all for selection sets. Now there's no alpha channels in these ones, but each one has been packed with a red channel, a green channel, and a blue channel separately as individual selection mats. And same here, red, green, blue. Red, green, blue. So we'll be able to use those to modify things. And then we've got this pass over here, which is kind of funky looking, and you're going to see this pass kind of funky looking. It's pretty cool. But what it is I had 3 passes that were essentially all scalar image passes. Scalar image meaning that they're all grayscale. And instead of packing them as 3 separate image sequences, I put them into red, green, blue, into one image sequence. So it's holding 3 different render passes in one image sequence without using an EXR, just using straight up 8-bit PNGs. So it's AO, shadow, and Fresnel. So if we look at the red channel, you can see the red channel is an ambient occlusion pass. And if we look at the green channel, these are all the cast shadows from the lighting from the trees onto the ground. And this shadow pass is particularly important because when we get our troll and we get his shadows, we want his shadows to combine correctly with our other tree shadows. So instead of rendering the shadows directly into the plate, by separating these as a mask, we'll be able to take the troll shadows, combine it with this pass, because they'll be both just implicit mats, and then combine them together with the same color correct and get a correct shadow combination. And you'll see that in greater detail next week when we do the troll. And then in the blue channel, I've got a Fresnel pass. And this Fresnel pass will allow me to put some moss on the trees and do some weird color corrections on the ground and things like that. And if we gamma it down, you can see you can choke the amount of Fresnel, either way. So it gives us a great latitude in that. So this pass is funkadelic and crazy looking, but it's very, very useful. And then lastly, this is the PMAP pass. And I want you to see the values down here. When I hover it over here, you can see that some of these values go into the hundreds. I got 165 in red, 170 in red, and it keeps going on and on and on. And what a position map is for those of you who don't know, is that every single pixel represents the X in red, Y in green, Z or Z in blue, XYZ coordinate of that rendered pixel for pixel. So this is a great pass to get dimensional information of where the locations of certain things are in Nuke, as well as we're going to use it to create some a different kind of fog pass. The main reason that I'm going to use this to create fog is because we have a moving camera, and fog is generally dependent on the position of the camera. And because this is a ride film, I don't want, like, when you're really, really far away, that it somehow it looks way foggier. So I'm going to use this to create a fog pass that doesn't shift dramatically based on the camera movement. It's more of an artistic interpretation than maybe necessarily a scientifically accurate version. We're going to jump over to a version of the comp that I put together, and I'm going to go over it with you. All right, so I'm going to bring in our ride base. So let's get a read geo and let's go up to our assets folder, and I'm going to bring in the ride base stereo, create an all-in-one node, and let that read the file in. And when this reads in, it should give us 4 cameras. And it's really important that we pick the right ones here. Okay. So there we go. We've got 4 cameras, an axis node, and a ride base stereo. And we can toss this right now. I've already tossed the axis. Now, we've got 4 cameras. I thought we only had 2. Let's take a look at this. And there we go. Let's think back to the way this looked in Maya. We've got our 3 cameras right there. So 3 cameras, 4 cameras. Well, remember, the first camera is the original camera, the one that we parented it to, the one that we set up initially. So, and we already have that one in here, so we can just chuck that. The second camera, that's that middle camera. And the stereo camera rig comes with a middle or center cam, which is fine for evaluating things and stuff like that, but we can chuck that too. We don't need that. We've already got a camera from before. What we do need is camera 3 and camera 4. And this is our stereo left cam, so let's actually rename it left cam and right camera. And then I'm also going to uncheck read from file so the animation values are here. Now what we have to do is we also have to make sure that our projection window scale is in there as well. One thing I wanted to point it out about the window scale is that one of our wonderful members, and this is one of the great reasons I love FX PhD, is our interacting with the members. Well, Jorg Mark from Germany figured out the math that was the relationship between what we did in Maya and what we're supposed to be doing here in Nuke. I figured it out artistically and visually, and that's where my problem solving skills always excel at, is that kind of visual side, but he figured out the actual math. And I just want to say thank you very much and hats off to you. But what we want to do here is in the window scale is actually, I came up with a value of 5.2, 5.26, but if we actually take the value of 1 and divide it by the value we put in Maya, so that was 0.19, it gives us 5.26315,789. So we can get that much, much finer because I just came up with 5.26. Basically take 1, divide by the value that we put in Maya, which was 0.19, and there we go. That's the correct value. So I'm going to basically copy these values and just paste them into the other areas. Now I will round it off. Let's just keep it. We'll leave that 1 extra decimal place. So it's a little closer. There we go. 5.263. All right. Once again, thank you. So now that we have our 2 cameras set up, they are stereo cameras. So we need to join them together with a join view node. This will allow them to be seen as a stereo pair, and they will render stereo pairs together. All we need to do now is hook that up. Jumping ahead, I've already done this composite, and you can kind of see, I'm going to jump down here and I'm going to show you what exactly we put together here. And, I've got some God rays coming through the fog. I've got some heavy fog, and I've got my trees, and I've got some lovely moss on some of the edges and stuff like that. And this is basically what our final look is. Now, let's look at how this was built from all the passes and we're going to talk about some of the cool strategies that I employed here. Now, let's jump all the way back up to the top here with our tree environment. Now, the tree environment, you can see I mapped it onto the dome, which was directly exported out of Maya. So that way we can have it just like this. Now, I wanted to be able to, there was a couple things here where the view that I was seeing, let's take a look at our camera here. The view that I was seeing from about this frame right about here, I was not happy seeing this really brightly lit tree. I could go in and do a little roto paint and move that, but I found an effective way of actually rotating the image of the dome without rotating the dome itself. Because if we look back at our dome, right, we have a pretty substantial, hold on, let me undock that camera. We have a substantial issue of like, well, the dome is constructed to fit this environment. We can't really rotate the dome. So how do you rotate a image that is basically an equatorial panorama? You can't really rotate that either. So what we're going to do is we're going to grab a spherical transformation and we're going to drop it right in between. And this spherical transformation is going to transform our lat long map, because that's what we're inputting, and we're going to output a lat long map. We're going to keep it exactly the same. And in fact, let's see what the resolution is, 6,000 by 3,000, and we'll make sure that is exactly the same. Now down here, output rotation order, well, we're going to rotate it on the Y. So if we do this right here, 90 degrees, that's actually rotating the image 90 degrees around the optical center of this spherical image. So we can actually just kind of move it around and rotate it that way. I'm going to put a frame hold on this. Now technically it probably should be fine without the frame hold, but that way it won't ever calculate that circle transform after frame 0. You can see it just kind of rotated that over just a few degrees. It's taken a little while to render this, but you can see that I got rid of that one bright tree. I also have a screen mask right here, and that was directly exported from Maya. And what that does is it just masks out the dome image so that way it has the correct shape. Now this also allows me to generate an alpha channel if I ever need it for that full size from this particular object. The scanline render has a constant that is setting it to render out 4K, and I have a stereo cam from the camera, which is all the way down at the bottom with the joined views, being piped up here, and I labeled it stereo cam and I hid the input so that way I didn't have to see that line crossing all over or duplicate the camera again. So we've got this going on right here, and then we come down here and we're splitting it off into two places. Now we'll come back to what's going on over here in a little bit, but the first thing is this main grade. This grade is to push the color a little bit more, kind of like a bright overcast day, and push a little bit more greens into it. And then we come over here to merge it on top. Now, here's my ground, and then I'm using a multi-matte, but I'm blurring the multi-matte severely and using the red channel with a color correct to darken and desaturate a couple of pockets on the ground and make that just a little bit more within the look that I'm going for. And then that gets merged on top of the trees. So there's our full frame of the forest, but we need to now bring in a shadow pass. So over here, I've got my shadows right here, and they are in the green channel. So I've got a grade node right here, and this grade node, what it essentially is doing is bringing the white point to 0.7. Now, the reason this is because these shadows were generated with soft shadows, soft ray trace shadows on the trees. And I can see that as I hover my mouse over these different areas, the green, which is where the shadows is about 0.7 in the density around here. And to have an effective mask to create the shadows, I wanted it to be at a value closer to 1. So that grade brings that up. And now you can see that the value in the green is much closer to 1. It's actually a little bit over, and that's okay. But we can select white clamp, and that'll keep those white values right there at 1 and not go over. But the 0.7 is literally saying I want my white point to be that 0.7 pixel, and it brings it up to 1. Let's go over to here, and there's the color of the shadows. So you can see this way we put the shadows directly onto the plate, and it's got some color in it. It's got some blue. It's right here I've got some blue light going into it, which is really important for realistic lighting. And this way, the shadows are completely separate. Like I said before, this way, when the troll gets in here, I can add that shadow to this pass right here before this color correct. And that way, the shadows will be of equal density and equal color. And I'll demonstrate that real quick with a roto. So I'll just connect a roto right here, and we'll draw a new shape into it. And this is a hypothetical troll shadow. All right, so we'll draw that shape into the alpha channel. We'll soften it a little bit. Add a little fade over here. And right now, it's not doing anything because this is not using the alpha channel. The color correct for the shadows is actually using the green channel as the mask. So because that's where our shadow is stored. So we have to remember that. So on this roto, I need to not output alpha, but output RGB, so that way it's also in the green. And now you can see that that shadow of that roto is, wherever I put it, it will equally contribute to the same color density. We won't have that double darkening of shadows. So I'm going to delete that roto and leave it out of there. And as we come down, I've got that going there, but now we've got our trees. Now our trees, they start out looking like this. And this is pretty nice. It's got some nice lighting, some nice textures, but I have the multi-mat, and then I'm going to be shuffling it into a new channel called multi-mats. And then through a layer copy, multi-mats, it's now going to be embedded with it. And you can see right here, it's now embedded inside of Nuke Stream, which is a really powerful way, and it's actually the preferred way of Nuke to be operating, is that masks be embedded and not use this input. In fact, this input was added to give people who were used to the way Shake worked kind of a legacy way of inputting masks. A few years ago, when I was using Nuke version 4, one of the first commercially released versions that D2 software had, we never had these mask inputs, and we always had to keep them embedded in the image stream. It's the preferred way, but essentially what's going to happen now is I'm going to take these trees and I'm going to color correct them. I give them a little bit more blue light. Right, so what's coming around here is basically I'm using the Fresnel pass with this color correct to kind of amplify the edges with this kind of like moss that is creating like a patina on the trees, and we only see it on those glancing angles. So it's just basically a color correct, really pushing that green, because once we get the fog in there, it's going to kind of bring it down. So I'm kind of overdriving it a little bit there. This grade is to manipulate the input of that. So if we need to switch that and like gain that up a little bit or gain it down, that will cause an effect on that. So let's just close that out. And then this gets placed on with some ambient occlusion. So we're shuffling out the ambient occlusion, grading it up a little bit, blurring it to get rid of some of the noise, and then it's being multiplied onto those trees. So you see that's giving it a little bit more darkness in the background than in the foreground. And then we finally put this over here. So I want you to see the different contributions. So over here, this is the moss. Right here. There's the moss. We add the moss in. This pass right here, this grade is using the blue from the multi-matte to kind of make some of these back trees be a little bit more brownish than the gray ones. And then over here, the ambient occlusion is adding some more darkness into the occluded areas and giving it a little bit better look. Now, down below, we're going to skip this right now. I want you to see what that causes. And we're using the P map right here to create a depth pass. So I've got a shuffle node that's basically shuffling out only the blue. That's because blue goes down the Z axis and our environment is set down the Z. And then we have a grade, and I want you to see this grade is basically taking the closest point, which is just around like about 6-ish, and it's taking that, making that black. And then way deep in here in the blue, you can see that it's going back negative numbers. So the white point is set to negative 230. What that does is it creates this right here. And what's really awesome is that by grading that data into visual terms, because those negative numbers have to be like brought forward, we can change the amount of fog. And you can see I'm rolling this mouse backwards, and we can really create some amazing depth out of this. That value is now being brought in as a mask. This mask over here is set to, this color correct, set to desaturate, lower the contrast, up some of the gamma, and brighten it, but it's all based upon this. So it creates a wonderful fall off into the background. But you can see that I've got these really horrific artifacts right here. And basically these artifacts are there because the pass up here has gone to 0 blacks. You can see if I raise my gamma all the way up here, there's 0. And when you got 0 blacks, it's very difficult to do anything. So you should always try to strive to not have 0 blacks in your imagery. Because a lot of color manipulations operate on multiply and divides, and anything divided by 0 or multiplied by 0 is 0. So we want to make sure that we don't have 0 in our images. So this color correct just offsets the shadows by 0.01 and lifts those blacks so they don't do that. Let's return to normal gamma, and it looks at virtually the identical, but now when we add the fog, it looks lovely. That looks hideous. That looks lovely. So now we have a beautifully fogged day, but the sun is coming out. It is breaking through. It's casting these wonderful shadows. So what I want to do is I want to add some light to that. So we've got some couple layers of fog here, and I've taken another layer over here and I've shuffled out the Y and created a gradient going up and added a little bit more green mist to the top layer, because all that fog is kind of attenuating the light through all those green leaves of the canopy. Thought it made for an interesting look. So then over here, I'm creating some God rays, some light shafts to come through the fog. And this is being, taking that same P map, and then we're grading it much more harshly and coloring it orangish colored. So you can see by the black point and the white point, I'm really able to like dial in a much smaller zone of color. And then because these values are so massive, you can see that we've got negative numbers in the alpha, negative numbers in the blacks. I've got a clamp on this that clamps everything with 0 to 1. And then we have God rays. And the God rays are spewing that image out basically by scaling it up. Now, I needed to get the center point of the God rays to be able to track with our shot. And that's where this up here, Reconcile 3D, comes into place. And looking at this node over here, Position the Points. See, Position the Points takes the PMap and it has an input for position, and this input over here is just a color image. And if I take a look at this, what we're going to do is it's going to create a point cloud of our forest. And that point cloud allows me to take a 3D object and position it in space relative to where it would be inside of this 3D scene. And so what I'm going to do is I'm going to put a point back here, which is exactly what I did. Put a point back there, which was a sphere. And then I copied the X, Y, and Z positional data into this Reconcile 3D node. And once this data over here of where that position is copied into here, and we connect this to our camera, and connect this to a image. In this case, I just used the image of the scan line of the trees. As soon as you hit create keyframes, it basically creates a X and Y output and an XYZ output of that position through the camera. Well, basically takes that point and translate it to a two-dimensional point in space. And that allows us to then attach that information, the X and Y output, up here. Hold down Control and Shift, click, drag to copy it up there. And that way now the God rays, as they move, are emanating from this point that I basically did a, for lack of a better word, 2D track from a 3D point, which is what Reconcile 3D does. So now that I've got those God rays, they get plussed onto our image. So let's close that data down. So there it is without the God rays, and now here is with the God rays. And what's really cool is because I used the P map to create the source, the guide rays actually are cutting through the tree lines and creating these wonderful parts. I have a 0.8 pixel blur on the whole image just to soften any CG-ness on here. And then that's the previs troll that I just wanted to pop in there for placement reasons. And then over here, this is just exactly like we always have had in the past. This is our view-dependent imagery screen correction. We've got our stereo cameras going into a join view, projecting this final composite onto our screen object. So if I were to find our screen object right about here, there it is. There's our screen object. And we connect this up. These stereo cameras are now going to project it onto there. And when we switch to the right view, it's actually jumping now to the right camera with the right view composite. So by joining these two cameras together and doing a join view into a single scanline render, this scanline render is actually going to render out stereoscopic files. And we'll be using the correct camera and the correct composite all through the pipeline. And that's what's wonderful about Nuke, is that it does such a great job at being a stereo pipeline. And you can see as I toggle back and forth, we have our stereo viewports. So don't forget that the scanline render has to be set up to UV mode, and it will render this out to the flattened version that you see right here. So go ahead and run this script and make whatever color changes that you want to do for your version of this. And we're also going to jump back into this environment in the coming weeks. I plan on creating some maybe some XGen or Paint Effects grass that is going to help fill out some details in here. So we may have a grass pass in the future. We can also, as things move forward, this is by no means done. We're just going to add to it. But the bulk of next week's class is to get our troll animation in there. So I'm going to be working on that. So there it is. So if you have any questions, hit me up in the forums. And until then, see you next time.